warahmatullahi wabarakatuh and good day to all. My name is Nurul Syahirah binti Jamahiri, and today I would like to present a little bit about my project for final year project. And the title of my project is Fabrication and Characterization of Hydroxyapatite and Polyvinyl Alcohol Nanofiber for Bone Scaffold. As an introduction, for your information, 2.2 million bone grafting procedures are performed, and bone scaffold is the implant material used in the bone grafting. First, in this study, we choose to fabricate nanofiber from hydroxyapatite and polyvinyl alcohol for bone scaffold application using electrospinning technique. The reason why I choose hydroxyapatite because it is a bioactive and biodegradable material. Meanwhile, for the polyvinyl alcohol, it has excellent biocompatibility, biodegradability, and good mechanical performance. And the objective of my study is to fabricate PVA and HAP plus PVA nanofibers, and after that to characterize the physicochemical of the nanofibers. And for the methodology, first we prepare the HAP solution. When we combine the nanopowder hydroxyapatite with the distilled water, we prepare for 1, 2, and 3 weight percentage, and then we stir for about 1 hour at 700 rpm. Then we sonicate for 1 hour. And for the PVA solution, we combine the PVA powder with the distilled water, and we prepare at weight percentage, and then we stir the solution for about 2 hours at 90 degree and 700 rpm. Then we mix both, which is HAP and PVA solution, and we stir for about 2 hours at 120 degree and at 700 rpm. Then we sonicate for 30 minutes, and lastly we perform electrospinning. And for all the nanofibers, we fix the parameter to 14 kilovolt, 0.8 milliliter per hour, and 15 cm, which is the distance between the needles and collector. And for the result and discussion part, as you can see, A is a result, is a nanofiber for PVA alone. B, C, and D is when we combine hydroxyapatite with the PVA at the 1, 2, and 3 weight percentage. And then we can see that from the result, the nanofiber is bitless because we use a solution viscosity at the critical value. And the reason why it's bitless because the chain entanglement among the polymer are strong. And then we also calculate the mean diameter and compare between the PVA alone and HAP plus PVA. We can see that the PVA alone has a large mean diameter because for the hydroxyapatite and polyvinyl alcohol, it have a good electrostatic repulsion, so it will decrease the fiber diameters. And then we also have the result from the EDX, which is energy dispersive X-ray, which is we calculate the element composition. As you can see at the PVA, there is no presence of calcium and phosphate, but for the PVA and HA, when the weight percentage increase, then the quantity of the calcium and phosphate also increase. Then for lastly, we also have do the contact angle, which is to test the wettability of the nanofiber. And what we can see is PVA alone has a very good hydrophilicity properties, okay, which is favorable for cell adhesion. And then when the weight percentage is increased, we can see that the angle is moved toward hydrophobic properties. And as a conclusion, I would say that 1% of hydroxyapatite plus PVA is the best for the bone scaffold application because it has a smallest average nanometer diameter of the nanofiber. Because when the smallest the diameter, the mechanical strength is improved. And besides, it also have the smallest angle, which is moved toward hydrophilics, and hydrophilic is good. It's a favorable environment for the cell adhesion and cell regeneration or proliferation. And I think that's all from me. Thank you.